Let's now use these points to determine the amount of students for each range. So we see between 40.5 and 60.5, we go from 41 to 13. So going from 41 to 13, that's going to be a difference of 28. So we have 28 right here. Then we see we go from 61 to 80. Let's see what that range is. That is going to be 57 minus 41. So we have 57 minus 41. That's going to be 8. 5 minus 4, that's going to be 1. So that's going to be around 18. Right, so then we multiply across. 28 by 50.5 is 14. Now let's do 18 by 70.5. That's going to be 1269. Right, so moving right along. Number 6, part A tells us a recipe for making 20 bite-sized cookies uses 175 grams flour, 125 grams of butter, and 75 grams of sugar. They want to write in its simplest form the ratio of flour to butter to sugar. So that's going to be 175 to 125 to 75. Each of these numbers are divisible by 25. So 175 divided by 25, that's going to be 7. 125 divided by 25, that's 5. Then 75 divided by 25, that's going to be 3. Right, so the ratio would be 7 to 5 to 3. Part 2 wants us to determine the amount of flour, butter, and sugar needed to make 52 such cookies. We know what the ratios would be for 20 cookies. That's going to be 175 to 125 to 75. So we now want to know what's the ratio for 52. So we know that 20 would have taken 175 grams of flour, 125 grams of butter, and 75 grams of sugar. So we then use that ratio, this 52 over 20, because that's how much more we need to determine the amounts. So that's 52 over 20 by 175. 52 over 20 multiplied by 125. And 52 over 20 multiplied by 75. Right, so let's work this out on the calculator. For the first one, I got 455 grams. For the second, I got 325 grams. And for the third, I got 195 grams. I hope you guys aren't hearing those cicadas in the background. If they are, please excuse them. They seem to be calling some rain. Right, so we have 455 grams of flour, 325 grams of butter, and 195 grams of sugar. Part B tells us that the cookies are made and sold in packs of 12. A bag contains 12.65 grams of flour. They told us using this information, complete the following statements below. They want us to show all working. So the first thing I would do is see exactly how much flour is required to make 12 cookies. We know that 20 cookies requires 175 grams of flour. Therefore, 12 cookies would require 12 over 20 multiplied by 175. Working this out on the calculator gives, that is 105 grams of flour. Right, so they're asking one bag of flour makes a maximum of how many packs of cookies. So we need to see how many 105 gram amounts we could get from the total bag, because this is the amount to make 12 cookies, which is one pack. We therefore divide our 12.5 kilograms by 100.5 grams. So number of packs of 12 would be our 1265 divided by 105. We need to convert this 1265 kilograms to grams. So we multiply by 1,000. So that's 1, 2, 3. That'll be 12,650. Now let's use the calculator. And that gave 120.48 packs. Now we can't have 0.48 of a pack, so that would be 120 packs we can make comfortably with the bag of flour. Right, so that's 120 packs. Then they want to know what is the amount of flour left over. So let's see exactly how much flour 120 pack requires. So that would be 120 multiplied by the amount required for one pack. So this would be the amount required for 120 packs. Right, so that'll be 120 by 105. Let's see. That gave 12,600 grams. Now the amount remaining will be the total amount minus the amount required. So that is going to be amount of flour remaining would be 12,650 minus 12,600. That gives 50 grams. So the amount of flour left over would be 50 grams. Moving right along. 7a says the diagram below shows part of a number chart. The numbers on the chart follow various patterns. We need to study the patterns and answer the questions that follow. Part 1 wants to know what number should be placed in column 1 of row 9. So column 1 is going to be here, and row 9 would be then 6, 7, 8, 9. Right, so if we notice the pattern, we are going to increase by, what's that, 7, 7, 7. We are increasing by 7 each time. So the 9th row of the first column would be 7 by 9. Sorry, actually yes, it would be 7 by 9. So 7 by 9 would be 63. Moving right along. Part 2 says the following diagram represents a given row from the chart described on page 22. They want us to fill in the 3 missing numbers in the diagram above. Let's deduce the pattern for column 2. So in column 2, we go from 9 to 16, then 16 to 23, then 23 to 30. That is an increase of, we're increasing by 7 each time. Let's see if we could get a general pattern for this. This is going to be 7 by n, and we have to add 2 to get to the number that we had. 7 by 1 is 7, plus 2, that's going to give 9. 7 by 2 is 14, plus 2, that's going to give 16. So the general pattern for column 2 is going to be 7n plus 2. Let's use this now to help us out. Right, so we know that this row here is going to be 7n plus 2. This row here is going to be 7n plus 2. So let's see now what is the n that makes this through. So 653 is equal to some 7n plus 2. Therefore 651 would be 7n. And here n would be 651 divided by 7. And that is going to be 93. Right, so this is going to be row 93. And now that we know what n is, we could use this information to follow out row 1 and row 3. Let's get the general pattern for row 1 and row 3. Well, row 1 would simply be 7 by n. So row 1's general form would be 7n. So we'll follow that in 1 second. Then row 3, let's see, we go from 11 to 18, that's an increase of 7. Then 18 to 25, that's another increase of 7, right? So increasing by 7 each time, right? So it's going to be 7, and it looks like 7 plus 4, 7n plus 4. So 2 by 7, that's 14 plus 4, that's 18. So the third row is indeed 7n plus 4. right? So this is going to be 7n plus 4. And if we know what n is, we could follow this information. So first let's find 93 by 7n, then 93 by 7n, 93 by 7 for this row here, this column here, and then 93 by 7 plus 4 for the third column. We're going to get 651 right here, and then 651 plus 4, that would be 655. Part 3 wants to know which row would contain the number 942. To do this, we need to see which of the general formulas, 7n rather, 7n plus 2 and 7n plus 4, which one of them would give us a whole number n when equated to 942. So let's test that. We have 7n is equal to 942. We have 7n, so let's do this first. So let's do 942 divided by 7. When we divided this, we get 135 point something, so it's not going to be this row, it's not going to be we're not going to use the row with 7n. So let's try then. 7n plus 2 is equal to 942. So therefore 7n would be 940. So let's see if this would give us a whole number n. And again, here we get 134 point something. So it's not going to be this one here. Let's try now. 7n plus 4 is equal to 942. Therefore 7n would be, that's 938. So let's divide both sides by 7 now. And so this gives 134 flat. Right, so we see that the row that is going to contain the number 942 would be row number 134. And that's because if we equate 7n plus 4 to 942, we see the n that makes that true is 134. So when n is equal to 134, 7n plus 4 would be equal to 942. And so that is my explanation of the reasoning. Part B, we have a sequence formed using diagrams made up of equilateral triangles constructed from sticks of unit length. The first 4 diagrams in this sequence are shown. The table below shows the relationship among the number of equilateral triangles, the number of sticks that form each diagram, and the number of dots. They want us to complete the table. So the first thing I do for these is get the general form, but for this one, that's all they want, the general form. So let's see, we increase by 2 each time. That's going to be 2n. And then we have, what's the difference between, actually no, that can't be 2n, because when n is 1, the first row would not give us, is not going to give us 2. Right, so let's see, this one here seems to be n, oh, here we go, I think I'm seeing it. So this seems to be 2n minus 1, because 2 by 1 is 2, minus 1 is 1, then we have 2n minus 1 again. Yeah, that's it. So we are increasing by 2n each time. But then we have to minus 1 to get back to the number we are at here. So 2 by 1 is 2. If we minus 1, we get back 1. 2 by 2 is 4. If we minus 1, we get 3. 2 by 3 is 6. If we minus 1, we get 5. So this one is going to be 2n minus 1. Let's see here now. So we go from 3 to 7. That's an increase of 4. 4 to 11. That's 4 again. So we're sure it's going to be 4n. And then it's going to be 4n minus 1 again, because 1 by 4 is 4, minus 1 is 3, 2 by 4 is 8, minus 1, that's 7. Right, the number of dots, we go from 3 to 5, 5 to 7, 7 to 9, we increase by 2 each time, that's going to be 2n and we then have to add 1, because 2 by 1 is 2, plus 1 is 3, 2 by 2 is 4, plus 1 is 5. So this is going to be 2n plus 1. Part 2 says using your answers in B part 1. This is B part 1. Show that the difference between the number of equilateral triangles and the number of dots will always be equal to 2. So we're going to subtract the number of equilateral triangles and the number of dots. Right, so we need to do that with the general form. So we say that 2n minus 1, that's the general form for equilateral triangles. We minus from that the number of dots. Number of dots is given as 2n plus 1. So that would be 2n minus 1 minus 2n minus 2n minus 1. Right, so that gives minus 2. Right, so we see the difference between these both of these are always going to be a difference of negative 2. Part 8, we have a quadratic function defined as follows.